Welcome everyone to Catalyst Conversations, the podcast where we bridge the gap between cutting-edge technology and strategic business leadership. Today, we're diving deep into a topic that's reshaping how organizations extract value from data, rethinking data analysis in the age of large language models, or LLMs. We have a fantastic panel of experts with us today to unpack a really intriguing approach called FLOCO, detailed in a fascinating paper from researchers at Williams, UMass Amherst, and UCLA. Let's jump right in. Expert 1, from a business strategy perspective, what's the core problem FLOCO seems to be tackling?
Great question to start. Look, businesses are drowning in data but starving for insights. We invest heavily in data science teams, but the process, well, it can be messy. Traditional tools like computational notebooks, while great for exploration, often lead to reproducibility nightmares and make collaboration tricky. We need faster, more reliable ways to get from raw data to actionable intelligence, especially as we try to democratize data analysis beyond just the hardcore programmers.
Absolutely, expert one. As someone who spends a lot of time in the trenches with data, those notebook issues are very real. You know, the classic problem of it worked on my machine, or trying to debug a notebook where cells were run out of order. It's like untangling spaghetti. Peskin, referring to a famous anecdote about debugging himself, would struggle. It slows down iteration significantly.
So we have this friction point with existing tools. Then enter LLMs, promising to write code for us. Expert 2, how have LLMs changed the game, and what are their limitations in this context?
LLMs are phenomenal code generators, no doubt. They can significantly lower the barrier to entry for simple tasks. Ask ChatGPT to plot some data and boom, you get Python code. But it's a big but it's often a black box. You get a chunk of code, but how do you verify it? How do you tweak just one specific step without the LLM rewriting the whole thing unpredictably? And managing a complex analysis via chat prompts alone, it gets unwieldy fast.
Exactly, and that's where this FLOCO concept comes in. It's trying to harness the power of LLMs within a structured framework. The core idea, leveraging a visual data flow programming model, isn't entirely new in computing. Think systems like LabVIEW or even TensorFlow graphs, but applying it as a mixed initiative system with LLMs for general data analysis is quite novel.
Mixed initiative. Can you elaborate on that? What does it mean in practice here?
It means neither the human nor the AI is solely in charge. They collaborate. The analyst uses a visual canvas, drawing nodes for each step of the analysis, load data, clean it, cluster it, plot it, and connecting them to show how data flows. This visual graph is the structure. FLOCO then uses an LLM to translate each node and its connections into executable code.
And crucially, this data flow model enforces modularity and explicit dependencies. Each node is essentially a function. Its output depends only on its inputs, which are clearly defined by the incoming edges in the graph. This eliminates those out-of-order execution problems and makes the whole analysis much easier to reason about, reproduce, and even debug. It's like building with Legos instead of sculpting from a single block of clay.
I like that Lego analogy. So the visual graph provides the blueprint, and the LLM is like a highly skilled, very fast construction crew building each part.
That's a good way to put it, and FLOCO integrates the LLM deeply, not just as a code generator. It helps define the requirements for each node based on its label and context in the graph. It powers an Ask Me Anything chat that understands the graph, the data, and the outputs. It can even help validate the generated code.
Let's talk about that validation. This seems critical if we're relying on AI-generated code. Expert 3, the paper mentions different layers of abstraction and checks.
Right, FLOCO allows interaction at multiple levels. You have the high-level summary label on the node, like cluster eruptions. Then there are more detailed prose requirements that FLOCO often generates or refines with the LLM, specifying what the node should do. Finally, there's the actual Python code generated by the LLM. Users can inspect or even edit at any of these levels.
And building on that, FLOCO introduces checks and tests. Users can define assertions in plain English about what a node's output should look like. For instance, verify the output data frame has two new columns, or ensure the list of bootstrap averages contains at least 5,000 samples. Floco translates these into executable checks.
This validation part is huge from a user perspective. One of the big anxieties with using LLMs for analysis is trusting the output. The user study mentioned in the paper highlighted this. Participants felt more confident in Floco's code because of these built-in checks and the structured approach, compared to just asking ChatGPT for a script. They could actually see the logic flow and add their own guardrails.
And that confidence translates directly to business value. If analysts, especially those less experienced with coding, can build and trust their analyses faster, it accelerates discovery. Think about scientific research, policymaking, or even just departmental analysts trying to understand customer behavior. Lowering the barrier while maintaining rigor, that's the holy grail. It addresses the democratization goal I mentioned earlier.
Let's consider a real-world example. The paper uses analyzing old faithful geyser data or Finch beak measurements. How would Floco make that process different from using, say, a Jupyter notebook and maybe ChatGPT on the side?
Okay, imagine the Finch beak analysis. In a notebook, I might load the data in one cell, then maybe plot length versus depth in another. Then decide to filter for one species, Fortis, in a third cell. Maybe I then calculate bootstrap confidence intervals in several more cells. If I later go back and change the filtering criteria in cell 3, I have to remember to rerun all the downstream cells, 5, 6, 7. It's easy to forget one, leading to stale results.
With Floco, you'd visually connect the nodes, load data plot length depth, and also load data select Fortis bootstrap average estimate confidence interval. If you modify the select Fortis node, maybe change the species or add a filter, Floco knows exactly which downstream nodes, bootstrap average, estimate CI, are affected and need recomputation. It handles the dependency tracking automatically because it's inherent in the graph structure.
Plus, if you get stuck on how to implement the bootstrapping, instead of crafting a complex prompt for ChatGPT and pasting code back, you create a bootstrap average node, maybe give it a simple description, and Floco, using the LLM, generates the requirements and code for that specific step, ensuring it fits correctly with the input data from the select Fortis node. The context is implicitly handled.
That makes sense. It sounds very streamlined, but no system is perfect. What are the challenges or potential downsides? Expert 6, perhaps you have a contrarian view.
Well, I think the tech is impressive truly, but I wonder if we're focusing too much on the code generation aspect. The paper mentions users worried about complex graphs becoming messy. That's a classic visual programming challenge. But maybe the deeper challenge isn't just managing visual complexity, but ensuring statistical validity.
Go on. Statistical validity versus code correctness.
Floco seems excellent at ensuring the generated code runs and meets the user's stated requirements via checks. But does the analysis itself make statistical sense? Did the user choose the right clustering algorithm? Is linear regression appropriate here, or should it be logistic, as mentioned in the mortgage example? LLMs can write statistically flawed analysis code just as easily as correct code if the prompt isn't carefully guided by sound statistical principles.
That's a really critical point, Expert 6. The paper acknowledges this implicitly by focusing on authoring workflows and mentions future work on statistical correctness checks. Building on what systems like T or Tizan explored in coding statistical knowledge and integrating that with this LLM-driven approach seems like a vital next step. Floco's framework, with its explicit requirements and checks, might actually be a good foundation for adding such statistical guardrails.
I agree with Expert 3. The current checks are more about implementation correctness. Does the output match the type? Does the list have enough elements? Expert 6 is pointing towards semantic correctness in the statistical domain. It's like the difference between a program compiling and running versus a program actually doing the right computation for the problem. Floco's modularity could help here, perhaps suggesting checks based on data types or distributions flowing into a node.
From a business standpoint, Expert 6's point is crucial for risk management. We don't want to empower teams to make flawed decisions faster. So integrating those statistical guardrails isn't just a feature. It's essential for responsible adoption in high-stakes environments like finance or healthcare.
Okay, that's a fantastic point about the next frontier being statistical soundness, not just code execution. What about other practical challenges? Latency, scalability.
Latency is definitely mentioned in the user study. Waiting for the LLM to generate requirements, code, or run checks can interrupt the flow. As LLMs get faster, this will improve, but it's a real usability factor right now. Floco can mitigate some of this with parallel processing of nodes and asynchronous calls, but it's inherent to relying on external models.
And the messy graph issue for complex analyses is real. While modularity helps, visualizing and managing a workflow with, say, 50 interconnected nodes needs careful UI design. The paper suggests hierarchical graphs as a future direction, allowing users to collapse sections into subgraphs, which seems necessary for complex, real-world projects. It's the classic abstraction principle applied visually.
We've talked about the what and how of Floco. Let's shift towards the future implications. Expert 1, if tools like this become mainstream, how does it change the landscape for data science teams and businesses?
I see a few key shifts. One, it genuinely could democratize simpler analyses, freeing up senior data scientists for more complex modeling and strategic work. Think the 80-20 rule, maybe Floco handles 80% of the routine transformation and visualization tasks. Two, it could accelerate the onboarding of new analysts.
I agree. It might shift the focus towards designing the analysis flow and interpreting the results, rather than getting bogged down in Python library syntax. Although, let's be honest, understanding the underlying code will still be important for debugging and complex customizations. We might see hybrid workflows emerge.
Hybrid workflows, like integrating Floco with existing tools.
Potentially, the paper mentions exporting Floco graphs to Jupyter notebooks. Perhaps a future version allows seamless back and forth. Use Floco for structuring the main pipeline and ensuring reproducibility, then maybe drop into a notebook for highly custom, intricate code within a specific node or for final presentation polish. It doesn't have to be an either-or situation.
And the underlying idea, using a structured representation, the graph, to mediate interaction with an LLM for complex tasks, might have applications beyond data analysis. Think complex configuration management, workflow automation design, maybe even scientific simulation setup. It's a pattern for human-AI collaboration on structured problems.
We're nearing the end of our time. Any final thoughts or a key takeaway for our audience of business and tech leaders? Let's go around the virtual room. Expert 5.
Focus on reliability. When using LLMs for critical tasks like data analysis, systems need guardrails. Floco's approach of modular generation, explicit dependencies, and built-in validation is a step in the right direction. Don't just accept the magic, demand mechanisms for verification.
For me, it's about user experience meeting power. Tools need to lower the barrier to entry without sacrificing control or rigor. Floco seems to strike an interesting balance, especially for that initial exploratory phase where notebooks often get messy. Keep an eye on tools that blend visual structure with AI assistance.
Remember the value of structure. Whether it's a data flow graph or another formalism, providing structure helps both humans reason about complexity and helps guide LLMs to produce more reliable, maintainable outputs. Good fences make good neighbors, and good structure makes good AI-generated code.
Embrace the mixed initiative paradigm. The future isn't just humans using AI tools, it's humans and AI collaborating. Systems like Floco explore how that collaboration can be structured effectively, moving beyond simple chat interfaces for complex, multi-step tasks.
My takeaway: look beyond code execution. As AI gets better at writing code, the human value shifts towards ensuring the right questions are asked, the right methods are chosen, and the results are interpreted correctly and responsibly. Statistical validity and critical thinking become even more paramount.
And finally, from the business perspective, this isn't just about technology, it's about enabling your people. Tools like Floco represent a potential leap in productivity and democratization, but adoption requires thinking about workflow changes, training, and building trust. Evaluate these innovations not just on features, but on their potential to accelerate insight generation reliably and responsibly.
Fantastic insights from everyone. We've gone from the pains of traditional data analysis workflows through the innovative blend of visual data flow and LLMs in Floco debated the crucial difference between code correctness and statistical validity, and looked towards a future of more collaborative, structured, and hopefully democratized data science. A huge thank you to Expert 1, Expert 2, Expert 3, Expert 4, Expert 5, and Expert 6 for sharing your expertise and making this complex topic so accessible. And thanks to our listeners for tuning into Catalyst Conversations. Join us next time as we continue to explore the intersection of technology and business strategy. This paper introduces Floco, a new system for data analysis. Floco combines visual programming with large language models. It aims to make creating data analyses easier and more reliable. Traditional tools like computational notebooks can be hard to manage. Using large language models alone lacks fine control and verification. Floco uses a visual data flow programming model. Users build graphs where nodes are analysis steps and edges show data flow. This approach provides structure, modularity, and explicit dependencies. Large language models assist throughout the authoring process. Floco translates the visual graphs into executable code using a language model. Nodes can be viewed at different levels like summary, requirements, or code. The system helps users explore data via an integrated chat interface. This chat agent can access the data, the graph, and analysis outputs. Floco includes mechanisms for detecting and repairing errors in generated code. It also allows users to add checks and unit tests for validation. These checks help ensure the correctness of the analysis steps. Checks can be quantitative or qualitative assessments, even for visual plots. A user study found Floco helps analysts author analyses successfully. Participants, especially those with less programming experience, benefited. They found the data flow model helpful for organizing complex tasks. Many preferred Floco to using large language models directly. The system increased user confidence in the generated code and results. One limitation noted was latency during interactions with the language model. Some users worried that very complex graphs might become hard to read. Future work aims to improve statistical validity checks. Enhancing error repair and managing graph complexity are also goals. Floco demonstrates a promising approach for mixed initiative data analysis.